question about number 4, so let me run through that quickly. I gave you a graph. So this is number 4 from the quiz you just turned in. Let me see if I can copy this graph quickly. So the curve here goes through pi over 6, it looks like. So we have a pi over 6, pi over 3, pi over 2, 2 pi over 3, negative pi over 6, and negative pi over 3. So that asymptote's here, here, and then it goes downward through pi over 6. Something like this. And I asked you to match the picture with one of the equations here. So I guess that's what we have to do. First of all, if you look at the answers, they're all either tangents or cotangents, right? So hopefully you're not thinking this is a sine anyway, right? This is clearly some sort of tangent. My first question, and you could actually use either cotangent or tangent, but which one does it look more like initially?
Cotangent.
Cotangent, why? It's going downward, kind of, right? So just as a reminder, what? Oh, that's weird. Just as a reminder, what does regular tangent look like? How do you graph tan x? It's a snake. What are the asymptotes?
Pi over 2 and negative pi over 2.
Yeah, initially tangent has asymptotes at pi over 2 and negative pi over 2. And then it's a snake going this way. And if I wanted another period of tangent, you guys know what the next asymptote would be? 3 pi over 2, because tangent repeats every pi. So you would go 2 pi over 2, 3 pi over 2. This will be a 0, because this is right in the middle, and this will be an asymptote. So from here, you can flip this and get the graph of cotangent really easily. This is tangent. So what do you have to do to tangent in order to get cotangent? Asymptotes turn into zeros, so this guy, which was an asymptote, will turn into a 0 on the cotangent graph, and this guy, which was a 0, will turn into an asymptote. So it was a 0, it goes to an asymptote. So just a reminder of what the cotangent graph looks like. You don't have it memorized, which is fine. It has a 0 at pi over 2. It has asymptotes at 0 and pi. And then it's a, how do you know, I mean, either you remember it or there's another trick, I guess, but how do you know it doesn't go the same way as tangent? I mean, you either have to remember that cotangent is always going the opposite direction as tangent, or you have to remember that 1 stay the same. That was the other thing we used, right? Where the tangent graph is up at 1. That's going to be exactly the same on the cotangent graph. So because 1 stay the same, this negative 1 will also stay the same down here. Now my question is, how does this graph compare to this graph? Since you all told me this looks more like cotangent, I want to be able to compare this to this. Talk to me about things like period. What's the period in this graph? Pi. What's the period in this graph? Pi. Why?
Just subtract the right vertical sims.
Right, so from negative pi over 3 to 2 pi over 3, right, the distance between these two vertical asymptotes, this is negative pi over 3, this is 2 pi over 3. If you want to know the distance, you just do right, final minus initial, right minus left. 2 pi over 3 minus negative pi over 3 will be pi. Right, so the distance between these two asymptotes is pi. What's that tell me about my equation? right? I'm trying to get an equation like A cotan bx minus c. What is this? What is the fact that the period is pi? Tell me here. B is 1, right? B is the thing that has to do with the period. B is, well, the formula is that the period is pi over b. So because the period is pi, b has to equal 1. So I have this one figured out. What about A? How do I figure out what A is? Well, A is how high this guy goes after a quarter period. But you got to be a little careful with that because, you know, a quarter period is pi over 4. So when you go pi over 4 this way, how high is this? That's the question. But really, it doesn't matter, right? Because all of your choices are 2 or negative 2. And so you know A is either going to be 2 or negative 2, and how do you know which one? Yeah, for cotangent, this is the usual shape of your cotangent graph. Cotangent usually goes down. So this is going down just like it should be. So I don't need a negative. This would reflect it and move it back, flip it back up. Okay, so I don't have a reflection. So B is 1 because my period is pi. A is 2 because really that's my only choice. I mean, you could look at the picture and deduce it, but it's a little easier, I think. So then the only question is, what is C? And how do you know that?
Pi over 6.
Excuse me. C is pi over 6.
Negative pi over 6.
The sword had trouble. I don't know, like I said, the sword had trouble.
Yeah. It's actually pi over. It's actually negative pi over 3 technically. And why?
Or positive pi over 3.
C is negative pi. C, the way I've written it, is negative pi over 3. And the way I know that is because if you compare it to the original cotangent graph, which way has it been shifted?
Right.
To the left.
To the left. Why? This is pi over 2, right? Your 0 is at pi over 2, and right here your 0 is at pi over 6, right? So it's been shifted to the left. Your 0's moved to the left. Now, C is technically negative because it's been moved to the left, but when you plug that into the formula here, that's going to make it a positive in your formula. So how do I figure out how far you've shifted from here to here? Subtract. If you want to know how far it is from pi over 2 to pi over 6,
So it's just been shifted over 2 quarter.
no, the quarter period is in pi over 4.
I mean, 2. What did I say? 2 notches.
It's been shifted over 2 of these,
Yeah,
just
that's
2
what
of
I
these.
said.
But then so if you know how far each one of these is worth, then you can just calculate it from that. How far is each one of these?
You asking me? Because
I'm not asking anybody. I'm asking you.
Okay.
I'll finish it this way, but how far is each one of these?
Just
How far is it from pi over 6 to pi over 3? Each one of these is pi over 6 here. So from 0 to pi over 6 is pi over 6. From pi over 6 to pi over 3 is pi over 6. Right? Because pi over 6 plus pi over 6 is 2 pi over 6. Is pi over 3. So, but whatever. If you didn't recognize that each one of these distances is pi over 6, that's okay. You could figure out how far it is between these two numbers by taking the bigger one and subtracting the smaller. This is where I should start. This is where cotangent usually starts. Or usually has a 0. But I want to know how far I've moved over here, so I subtract pi over 2 minus pi over 6. And you get a common denominator, you do times 3. So C will equal 3 pi over 6 minus pi over 6, which is 2 pi over 6. But again, it was shifted to the left. So technically this should be negative. So what should my final answer be when I write the equation? Y equals what?
2 cos
2, because that's my only choice. Cotangent of, I knew b was 1 because of my period. X, and then should I put plus pi over 3 or minus pi over 3?
plus 4.
Plus pi over 3 because I moved to the left. I always put the opposite sign of the way I move.
Bravo.
So, this was a thinking problem. It was a thinking problem. A little bit. I mean, a little bit. A little bit.
Was that B?
Oh, I don't know. Was that B?
Yeah.
Yes. Then I hear yes.
I was bouncing around like E and F for a long time. It's just because I wasn't sure if it was negative or changes.
I thought there was a typo, because 2 of them were the same answer.
Were they?
Yeah, it was like C and E, and they were both tangents, so I was thinking one of them was supposed to be negative.
Oh, gotcha. Well, no.
Yeah,
They're
for
just
me
both
now
wrong.
too.
Just both wrong.
That's evil.
I mean, it was a typo, but it doesn't matter. Didn't matter. So that made you confused.
Can we go over problems?
Yeah, do you guys have any homework questions for me? From the inverse function stuff, I guess, right? That's the last thing that's covered fully.
Uh, 67,
Section.
7.3.
Okay, the equations. Oh, we might not have gotten this,
Oh,
but let me hear it. So I don't know.
cosine x equals negative sine negative x.
Yeah,
Oh, okay.
My advice to you, I will do, I don't know if I'll do anything similar to this, but my advice to you, if you want to go home and try this later, first you can pull this negative out. You know how it works?
Because it's odd.
Since it's odd, the negative can come out front. That's just a simplification to make your life easier. And then what I would do, because these are not the same trig function, we're going to cover this in type 4 other equations when you don't have the same trig function. You want to try to apply an identity to make them the same trig function. And one trick you can use to do that is to square both sides. So the reason I'm doing that is because I have an identity for cos squared or sine squared. Right? I know back in my Pythagorean identities that sine squared x plus cos squared x equals 1. So I can use this to say, for example, sine squared x equals 1 minus cos squared x. So then in here for sine squared x, I can replace it.
See, that's weird because the book does not explain that at all, but they still put it on their homework.
Yeah.
Well, actually, no, wait. Yeah, they kind of do. Never mind.
You have an example like that?
I think I remember that.
And then since you have cos squares, you can collect them. So this will get you started. If you
I
want.
thought we were supposed to do 7.3 on the break. Or,
No, I started it beforehand, and I did the easy ones, but 67 is kind of a little further. So you went ahead, which means you'll be super prepared. What else? Did you guys try anything from 7.1, 7.2, or the beginning of 7.3? If you didn't understand it, it's okay. I'll get to this. Anything I can help you with.
Wait, so what's the answer?
I didn't get to the answer.
Oh.
I'm not concerned with the answer. I'm
Yeah,
concerned with how to do it.
Okay.
Yeah, so there's a little more work to do at this point, but since I haven't talked about this yet, I'm not going to do it. But I wanted to give Walter a path. Did you guys try any of the inverse function stuff?
I 5 problems on 7.2, number 11.
Sure. What that?
Tangent, then in brackets, inverse cosine.
Okay. Tangent of cosine inverse.
Yeah. And then negative rectangles.
This is number 11. Okay, so I taught you, well, I don't know about teach, that's a strong word. I showed you a method to deal with trig functions composed with inverse trig functions where you draw a triangle. Okay? And I can draw a triangle and do this problem, and it's not hard. Okay? However, because this is a special ratio, this is a ratio that appears on the unit circle, you can do this without a triangle. Okay? If this were like 4/5, you would need a triangle. But because root 3 over 2 is on the unit circle, because it's one of our ratios that we know things about, we can do this without a triangle. So one way to tackle this would just be saying, okay, can I calculate what cosine inverse of negative root 3 over 2 is? Or can I find the angle, right? This is an angle that makes cosine equal to negative root 3 over 2. And, well, yeah, I can do that. I just go to my unit circle, or, I don't know, my table, or however I memorize my cosine values. Negative root 3 over 2 is going to be somewhere over here. And actually, it ends up being down here. So what angle makes cosine negative root 3 over 2?
5 pi over 6.
5 pi over 6. So I actually can calculate this inverse function here because of this special ratio. Now, quick question, how come I didn't use, there's another place on the unit circle where the x value is negative root 3 over 2. Right? Right down here, I have an x value negative root 3 over 2, negative 1 half. And this is at 7 pi over 6. Why am I going to choose 5 pi over 6 for the answer to this first part and not 7 pi over 6? Yeah, it passed the restriction for cos inverse. Remember, cos inverse is always between 0 and pi. Right, so you have to be in here for cos inverse, which is why we're going to pick 5 pi over 6 for this first part. So which means in place of cos inverse of negative root 3 over 2, I can put 5 pi over 6. And then move on and do my tangent. Right, so I have not done this tangent portion yet. So I have to bring that down. I have solved for the cos inverse. That was the angle 5 pi over 6. And then I actually have to calculate tan of 5 pi over 6. How do I do that? Unit circle. Tangent is x over y? Y over x, right? So on the unit circle, you will go to 5 pi over 6 and plug in whatever y over x is. Or 1 half over negative root 3 over 2. So you flip it up, this becomes this becomes 1 half times negative 2 over root 3. The 2's cancel, this is negative 1 over root 3. Or after you rationalize, negative root 3 over 3. So tangent of cos inverse of negative root 3 over 2 is negative root 3 over 3.
It's still
Tangent does. Regular tangent does. So this is not the way I showed you to do it, okay, but this is a valid method if you happen to recognize this as a special ratio. Now another method I showed you is to draw the triangle, and I think that's a useful thing, so I'm going to go over that too. So what I could have done, if I didn't notice anything about negative root 3 over 2, I didn't notice that was a special ratio that's on my unit circle, I could have said, all right, well, let me rephrase this question. Okay? I know cosine inverse is always an angle. And it's the angle that makes cosine equal to negative root 3 over 2. So what this problem is asking is to find tangent of theta, to find tangent of this angle, given cos theta equals negative root 3 over 2. And to solve this problem, you can draw a triangle. The most important thing, I think, about the triangle method is to figure out the quadrant that your triangle lands in. How do you know the quadrant to draw your triangle in? It comes from two things. Okay? It comes from the fact that cosine is negative. So as far as the quadrant of theta, which is your first sort of question mark here, when you're doing the triangle method, you need to note cosine is negative. So that's going to narrow down your quadrant. What's the other piece of information that you need? The restriction for what? Cos inverse, right? The fact that cos inverse can only be in a couple of quadrants, right? Cos inverse has to be between 0 and 5. So for your quadrant of theta, when you draw this triangle, you know that cosine is negative and cos inverse is between 0 and pi. So what quadrant does that put you in?
2.
Probably 2. Since our answer ended up in 2 here. Slightly more rigorously, cosine being negative, all of them are positive here. Cosine's still positive over here because x is still positive. So these are the two quadrants where cosine is negative. And these are the two quadrants where cosine inverse exists. So you know that your triangle has to end up quadrant 2. So you draw it. Triangle. Now, how do you label the sides?
X over Y.
So I know,
X over R.
yeah, cosine is adjacent over hypotenuse, so x over r. So I know right here that I have adjacent on top and hypotenuse on the bottom. So am I going to make the adjacent negative or the hypotenuse negative? Right, the hypotenuse is never negative. So you make this side negative root 3, you make this side 2. You do your Pythagorean theorem. A squared plus b squared equals c squared. Right, negative root 3 squared plus b squared equals 2 squared. And you get that b has to equal what? Okay, 3 plus b squared equals 4. B squared equals 1. B equals plus or minus root 1. How do I know whether to take the positive or negative? Going up. Right, we're on quadrant 2. So my vertical distance here has to be a positive 1. So then you get tangent by doing, well, tangent is always and forever opposite over adjacent. Negative 1 over negative root 3, I guess. There we go. Rationalize it, so it'll be negative root 3. First way is probably faster, but the second way will work no matter what ratio I